Welcome back to G Fun Facts Online, your go-to channel for the most intriguing bites of science and tech. Today, we're rocketing off to the red planet, Mars, to unravel a mystery that's had scientists buzzing for years, those enigmatic dark streaks that snake across its surface. For a long time, these were like tantalizing mirages, hinting at the possibility of flowing liquid water, a huge deal for finding life, right? Well, hold on to your helmets, because artificial intelligence has just thrown a major plot twist into this Martian saga. Imagine this. You're looking at photos of Mars, and you see these dark lines appearing, growing, and then fading with the seasons. These are the famous recurring slope lineae, or RSLs, first spotted in detail by NASA's Mars Reconnaissance Orbiter back in 2011. They pop up during the warmest Martian times. They creep down slopes, and then they vanish, only to show up again in the same places. It looked so much like seeping water, didn't it? The idea was that maybe salty water, which freezes at lower temperatures, was melting and flowing. And if there's liquid water, could there be life? Or at least a vital resource for future astronauts? The excitement was palpable. But let's get a reality check. Mars today is incredibly cold and dry. We're talking an average global temperature of around -83 degrees Fahrenheit or -63 Celsius. Brrr! While we know Mars probably had rivers and lakes billions of years ago, current conditions make it tough for liquid water to hang around on the surface. Now, it's important to know there are actually two main types of these dark markings. There are slope streaks, which are broader, darker features that can appear suddenly on dusty slopes and stick around for years, even decades. Scientists think these streaks move enough dust each Martian year to rival several global dust storms. Then there are the RSLs, which are narrower, shorter-lived, and have that distinct seasonal behavior. It was these RSLs that really got everyone thinking about water. So how do you solve a mystery like this from millions of miles away? You bring in the big guns, artificial intelligence. A research team from places like Brown University and the University of Bern decided to unleash machine learning algorithms on this problem. They trained an AI on confirmed sightings of slope streaks and then set it loose on a massive dataset, over 86,000 high-resolution satellite images from the Mars Reconnaissance Orbiter. Think about that. This allowed them to create the most comprehensive global map of these features ever, cataloging over 500,000 individual slope streaks. Dr. Adomas Valentinus, one of the researchers, pointed out how this big data approach helps rule out hypotheses before we even send landers. And what did this AI-driven analysis reveal? Well, it painted a surprisingly dry picture. When the team compared their massive map with environmental data like temperature, wind, and mineral composition, they found no strong evidence supporting wet processes. Most streaks didn't line up with temperature spikes or conditions suitable for liquid water. Instead, the formation of both slope streaks and RSLs showed a strong link to peaks in dust deposition and increased wind speeds. The conclusion? These features are most likely dry, granular flows, essentially Martian dust avalanches. Think of fine dust suddenly sliding down steep slopes. What could trigger these dust avalanches? Several things. Marsquakes could shake the dust loose. Strong winds could kickstart them. Meteoroid impacts nearby could send shockwaves. Even dust devils and rock falls seem to play a role, especially for RSLs, which often appear in regions where these are common. As Valentine Bickel, another co-author, explained, once they had the global map, they could cross-reference it with other databases to see what conditions best matched the streaks formation. And their model clearly pointed to dry processes. This actually lines up with some earlier research from 2017 by the U.S. Geological Survey, which also suggested RSLs were more like dry sand flows. This whole discovery really highlights the incredible power of AI in planetary science. Humans alone would struggle to sift through that much data. But AI can rapidly process and spot patterns, acting like a super assistant to scientists. It's this teamwork between human smarts and AI power that's really speeding up how we learn about other worlds. So what does a drier, at least in these spots, Mars mean? First, for present-day habitability, if these streaks are dry, It makes these specific locations less likely candidates for finding current life that relies on surface liquid water. Second, it's actually good news for planetary protection. If these sites were wet, we'd have to be super careful about accidentally contaminating potential Martian ecosystems with Earth microbes from our spacecraft. The dry hypothesis eases those concerns a bit for these particular features. And third, for future exploration, it helps us refine our strategies. The search for Martian water isn't over. It just means we might focus more on subsurface ice, hydrated minerals, and other geological clues. It's super important to remember, this research is about these specific streaks. The evidence for past water on Mars, ancient river valleys, deltas, lake beds, is still absolutely solid. And we know there's a ton of water ice under the Martian surface, especially at the poles and even in mid-latitudes. Remember that dramatic meteoroid impact in 2021 that actually ejected boulders of ice? Yeah, Mars definitely has water, just maybe not flowing on these particular slopes in the way we once thought. The story of water on Mars is an evolving one. AI has helped us clear up one fascinating illusion, but it's also given us an even more powerful tool to keep digging into the red planet's secrets. Every discovery, even one that shifts our old ideas, gets us closer to understanding Mars and its potential to have harbored, or maybe even still harbor, life. Thanks for tuning into G Fun Facts Online. Join us next time as we explore more wonders of science and technology. Stay curious.